Hello, welcome back. Today we're going to be talking about graphing linear functions using slope and the y-intercept. By the end of this video, you should be able to graph a linear function, meaning a line, using its slope and its y-intercept. Take a look at the following graphs and see if you can find a pattern between the slopes of the graphs and their equations below them. As we look at the first graph, we notice it has a slope of, well, we have to pick 2 points. And we find our rise over run. Our rise is 1, 2. Our run is 1, 2, 3. Which means our slope is 2/3. Oh, cool. Notice the 2/3 shows up next to the x. It's the number times the x. Let's take a look at the next graph. We're going to pick 2 points, 2 places where it crosses through a corner. Your rise is -1. And your run is 1, 2, 3, 4. So your rise over run, or your slope, equals -1 over 4. Look, that also shows up in the equation right here. Your rise over run, -1 over 4, is the number times the x. What about the -4 and the 3? Well, as you look at the equation in the graph, you might notice there's a -4 where the line crosses the y-axis, and that number shows up in your equation right here. It's the number being added to or subtracted from the x. Does the same pattern hold for the second equation? +3. Sure, you notice there's a +3 in your equation, and that also shows up on the graph where the line crosses the y-axis. Take a look at these two graphs. Do you see a same relationship between their equations and their graphs? Take a moment and see if the slope shows up on the graph and the equation, and also see if the number added to or subtracted from the x also shows up on the graph and the equation. For the first example, you might have found a slope of 1, 2, 3 over 1, which is the same thing as 3, and notice that again shows up in our equation. You might have also noticed that it crosses the y-axis at a +1, which shows up right there. This next equation looks a little different. Notice the x did not come first. So let's see if that shows up in our graph anywhere in the same way. Your rise over run, pick 2 points. You had to go down 1 and to the right 1, which means your rise over run equals -1 over 1, or just -1. But do you see -1 show up anywhere in your equation? The answer is yes. It's an understood one. Anytime you have an x without a coefficient, the coefficient is understood to be 1. So the -1 does show up next to the x. What about the +5? If we look at our graph, notice the line crosses the y-axis at 5, and that also shows up in our equation. This leads us to our definitions of the day. The y-axis intercept, or y-intercept for short, is the point where the graph crosses the y-axis, which leads us to our slope-intercept form of a line. The general form is y equals some number times x, so x has a coefficient of m, plus b. b is a constant, where m is the slope of the line. That's the number times x. And b is where the line crosses the y-axis, and it's called the y-intercept. The equation is written so that y is a function of x. In other words, y is by itself, and the mx comes before the b. That's a lot of information. Let's take a look in a slightly simpler form. I made it really large for emphasis because this equation is real important for a lot of what we're going to be doing this year in Algebra 1. Notice the m is the slope of the line. The b is where the line crosses the y-axis, or it's the y-intercept. Again, notice the mx comes first, the b comes second, and the y has to be it by itself. Go ahead and try to find the slope and the y-intercept of the following equation using what you know above. The y-intercept is going to have a little bit of a tricky part to it, so try to find it on your own and we'll talk about it together. Go ahead and press pause, find the slope and y-intercept, and press play when you're ready to see the answer. Okay, the slope. The slope is the number times the x, so your slope is 2. What about the y-intercept? Well, if we had a graph, the y-intercept would be where the graph crossed the y-axis. It's going to cross the y-axis at -1. If you remember in a previous clip, I told you that the y-intercept was a point. What point would this be? It would be x would be 0 and y would be -1. So our y-intercept is 0, -1. Our slope is 2. Go ahead and try this one real quick. Again, find me the slope and the y-intercept. Your slope should be -3. Your y-intercept should be 0, 2. Because that's the point where the line would cross the y-axis. Right here at 2 on the y-axis, which is the point 0, 2. Try to find the slope and the y-intercept of this equation. You might have some difficulty because the equation is not in the correct form. Y is not by itself, rather y is not a function of x. The mx didn't come first on the other side, and the number isn't second. So what we need to do is we need to rewrite the equation so that y is a function of x. I'm going to box the y, and we're going to solve in, as usual, SADMEP order. So let's undo subtraction addition. Notice the 3x is being added to positive 3x, the negative 2y. So to get rid of a positive 3x, we subtract 3x from both sides. This leaves us with negative 2y equals, now the negative 3x I'm going to write first, so my mx term comes first. So I write the negative 3x, it can't combine with the 6, so I have to write plus 6 because it's a positive 6. Then I need to get the y by itself still, so I box my y to tell me I need to get y by itself, and I'm going to divide every single term by -2. All I need to do now is reduce my fractions. Give me y is equal to a -3 over -2 is a positive 3/2. I'm going to write my x out front because it's 3/2 times x, which is the same thing as 3x over 2, plus 6 over -2, which is -3, which we could just write as -3. This leaves us with our slope equal to 3/2, and our y-intercept, which I'm going to abbreviate y-int, is equal to 0, -3. So again, to find the slope and the y-intercept, I need to rewrite the equation so y was a function of x, making my mx term first and my number second. Go ahead and try to find the slope and the y-intercept of the following equation. To work this one, again, I'm going to box the y, and to get the y by itself, we're going to go in SADMEP order. So we're going to undo the -8 by adding 8 to both sides. I'm going to add my positive 8 to the positive 3, giving me 11. 8 and -8 will cancel, leaving me with 2y is equal to 11 minus 4x. To get y by itself again, we're going to undo multiplication by dividing every term by 2, leaving us with y is equal to 11/2 minus 4 over 2 is 2x. Notice it is not in the right order, so I need to write the x first. And keep in mind that that's a negative 2x, so when I write the x first, I need to write negative 2x. And this is a positive 11/2, so I'm going to write plus 11/2, which means that my slope is -2, and my y-intercept is 0, comma 11 halves. We're now going to bring everything we've learned so far together into accomplishing our objective for the day, which is to draw a graph of a line without a table by using the slope-intercept form of line. The steps to doing that is we need to write the equation in slope-intercept form, y equals mx plus b. Then we need to plot the b. That's where the line crosses the y-axis. And then we need to start from the b and plot at least 2 more points using the slope as rise over run. Here's the equation I give you. Notice the first step is already done with our equation. It's already in y equals a number times x plus or minus another number form, y equals mx plus b. Now what we need to do is, keeping those steps in front of you, we need to plot our b. Notice our b is -4. So the -4 is where the line crosses the y-axis. It crosses right here. In order to draw a line, we need at least one more point. To find that other point, we're going to use the rise over run, or slope, of our line in order to, again, find the other point. Our slope is 2/3. 2 stands for our rise, and since it's a positive 2, we're going to go up 2. Our run, which is a positive 3, means we're going to go to the right 3. But up to right 3 from where? The steps tell us that we're going to start from the y-intercept, and we're going to go up 1, 2, and over 1, 2, 3. That's going to give us a second point on our line. Again, the way I did that is I started from the y-intercept and I went up 1, 2, and to the right 1, 2, 3, using our slope, which is a 2 over 3. We don't need the additional lines. All we really need is the 2 points. Now I can find a third point by going up to 1, 2, to the right 1, 2, 3. I can find a fourth point by going up 2, to the right 1, 2, 3. And I can keep on using that pattern over and over and over again. And all my lines should end up, all my points should end up lying in a straight line. Now we can go back to our y-intercept. We can go up 2 to the right 3, but how else would I land on the line? I can also go down 2 and to the left 1, 2, 3. Down 2 to the left 1, 2, 3. So we see that we can use our rise over run by going up to the right or down and to the left, and that creates all of our points on a straight line. Assuming I could draw my line exactly on the points. Go ahead and try to graph the following using slope-intercept form. Note that the slope is -1 over 4. That negative sign can be either put on top or on bottom. It may be easier to put it on top in order to graph. Go ahead and pause the video, graph the equation or the function, and press play when you're ready to see the answer. Our y-intercept was 2, and our slope was -1 over 4. So we went down 1 to the right, 1, 2, 3, 4. Down 1 to the right, 1, 2, 3, 4. Or we can go from the y-intercept and go up 1 to the left 4. Either way, all the points should lie on a straight line. And here's our last example. Graph this one in slope-intercept form. Note that it has to be in slope-intercept form first. Go ahead and press pause, work it out, and press play when you're ready to see the answer. Alright, I went ahead and got the 4x on the other side by subtracting 4x from both sides, and now I have a -y. So I'm going to get rid of that negative sign by dividing everything by a -1, which essentially just changes all of the signs. Now you might have gotten stuck. You're like, how do I graph a +4? So first you plotted your y-intercept, a 1, but now you have this 4. Well, your rise over run would be 4 over 1 because we can divide by 1 without changing the value of the 4. So our rise should be 4 and our run should be 1, giving us 1, 2, 3, 4 over 1, 1, 2, 3, 4 over 1. And we should be able to have a straight line going through those points. And there you go. That's graphing equations in slope-intercept form.